Let's talk now about our constant companion, the moon. There are so many misconceptions that I hope we can get busted with this little discussion. So, first of all, the moon looks so different every single day, although there is actually a cycle, and the duration is about 28 days. All right, it kind of looks full. It looks like a crescent and like a gibbous, and then it's full. Oh, here is just half of it visible. But is it just half? Some of you might know that actually the name is quarter, and that is because it's half of a half of the whole moon that we get to see. All right, that. Here's a time, just an example. This is you, of course, and you can actually do this experiment. Just get a grapefruit or I don't know, baseball or something, and have a directed light in a corner of a room, and just turn off every other source of light and look at what you see, okay, of that baseball, which is your moon. How much of it is going to be illuminated while you obviously rotate, okay? And the key here, and also what you need to do in this experiment, is to spin your baseball or grapefruit at the same rate at which that baseball is rotating around you. All right, so this is what the moon is doing. This is called the synchronous rotation because it's the same period of time in which the moon itself spins around its axis while it goes around the earth. So it's the same amount of time. And this is the exact reason for which we only are able to see we from the earth, whether we're here or here or here, just any direction, we're only going to see one single half of the moon, the face that is towards us. The other half is just not towards us, so we're not going to be able to see it. All right, obviously only half of the moon is going to be illuminated by the sun, right? The sun is here, okay, and here's the sunlight. All right, so this is the direction from which the illumination comes, right? So every single day while the moon is going to rotate around the earth, okay, you're going to see only a fraction, right, of that face that is towards you, the face of it that is towards you, that is going to be illuminated by the moon. And so this is what produces the various phases of the moon. Okay, we're going to talk a little bit about this, but this is basically the idea. It would be great if you can actually run this experiment. Oh, so based on what we learned so far, basically, what would you answer to a question like this? Suppose you're living on the moon and you're looking at the Earth. So now, as seen from the moon, how often does the Earth set? Basically, how often would the Earth go below your horizon, you living on the moon and looking at the Earth? Okay, so the correct answer is A, or never, because you are on the moon and you are seeing, right? So this is Earth, moon, this is the face, Earth, things, see, all the time, right? So if you're on the moon and you're looking towards the Earth, you're always going to have this same face towards Earth. So basically, whether you're here, or here, or here, or here, or here, anywhere in its orbit, of moon around Earth, anywhere in this orbit, if you're looking at the Earth, Earth is always going to be above your horizon, so it will never rise or set. Okay, all right, maybe a trick question, just think about it. Okay, so during that orbit, this is the moon, this is the Earth, obviously. This is an applet on a mastering astronomy that I think you're going to be encouraged to play with in your homework. You're going to see how much the sunlight is going to allow for the moon while it's moving around to be illuminated. All right. Obviously, in the situation that is presented exactly in this picture, right, you don't see much actually at all of the moon, right? So that's why there is nothing here. There is the name for that, people came up with that. That's a new moon. And as the moon moves in this direction, you get to see more and more and more. Okay, so therefore it's waxing. The moon gets fuller and fuller, and as we'll see a little later, it rises later each day. I'm gonna try to explain to you why. Okay, so it becomes fuller and fuller. That crescent becomes half of the moon that is visible from the Earth, therefore a quarter, and it is the first. And then that quarter becomes a little bulgy, becomes the gibbous, and then that gibbous becomes full, which is actually half of the whole moon, but it is still the full face that we can see. All right, so it does make sense to be called a full moon. All right, so as we will see, the full moon, that's here. This is the position for the full moon, right? Because you're gonna have plenty of sunlight reaching that point. You basically see everything of the face that is towards us. And then as it moves in its orbit, it's going to lose some of that angle. It's going to become a gibbous, but now it's waning, becomes less full, okay? And then it becomes less and less full, and you get to the last or the third quarter, okay? Hey, this one is also like 2 quarters, right? So it's second quarter, although nobody calls the full moon a second quarter. So that's why you have actually the last quarter being the third quarter, and then it becomes even less fuller and it becomes a waning crescent. Okay, so here's some here's some explanations as to, hey, when is it that we are actually seeing these different types of moons on our morning or evening sky. So here's a diagram that I think is going to help. So if the sun is here somewhere and it's big and it's far away and it sends the sunlight towards the earth, all right, the earth that has, so this is the earth, and it has the moon orbiting around it. So we have moon's orbit. Okay, of course this is not to scale. The sun is much further away than how is drawn here. If the moon is here, obviously you look at it. Let's do it again. All right, so you look at it, you won't see much. This is the new moon. Okay, if the moon is here somewhere, you're going to get to see all of it, all of the face toward the earth. So basically all, this is the whole or full moon. So whatever is hashed is the illuminated by sunlight. All right, so can you imagine you're on the earth and you're seeing the moon, say in this situation, is going to become very little illuminated, and this is the illuminated part. This is what you see, how you see it. Now you being kind of upside down. If you're looking from this side of the earth, if the moon is here, okay, you're going to see this part illuminated. So the hashed part is always illuminated. Obviously that's the quarter, right? So this is the first quarter. A quarter of the whole moon is illuminated. What's the name of this one? That's going to be, right, the moon becomes fuller and fuller and fuller. This is the waxing crescent. All right, so we have the first quarter here, the waxing crescent, a new moon. The moon becomes fuller and fuller, so the part that is illuminated looks like a gibbous, and it is a waxing gibbous. And then it becomes less fuller, so this would be the waning gibbous. Let me put the full moon here into, okay? And then here somewhere is the last or third quarter, okay? So it's gonna look like this, obviously. The sunlight gets to illuminate this, and you actually see that being now not upside down, right? So this is the illuminated part. This is the dark part. Okay, here somewhere we're back to the only a tiny bit of it being illuminated. That's the waning crescent. Now we got here. That's what I wanted to make sure you understand. So, for example, when are we seeing that new moon? Well, look at that. It needs to be So when you see, that's your eye here somewhere. When do you see the new moon? It needs to be when the sun is straight up. Look at that. This whole sun needs to be in the same direction. When is the sun straight up? Well, that is at 12 p.m. or noon. Let's think about, when do you see the full moon straight up? Well, you're looking in this direction. Where's the sun? The sun is under your horizon. This would be your horizon. If you're looking that direction, you are looking. Where's the sun? It's in the opposite direction. It's the middle of the night. Okay, so when are you going to see the full moon straight up in the sky? That is going to be 12 a.m. or midnight. Let's think about some other situations, right? When you think you're going to see straight up the first quarter, well, it needs to be halfway between 12 p.m. and 12 a.m., right? So I think that is 6 p.m., okay? And you keep going. This needs to be 9 p.m. This next needs to be 3 p.m. and so on. We get to 3 p.m., 6 p.m., a.m., sorry, right? After midnight, 3 more hours, 6 a.m. and 9 a.m. 3 more hours, you get to 12 p.m. So this is actually when you expect to see the times you expect to see straight up, like at their zenith, these different types of moons, right? So remember, the Earth rotates around its axis, right? And the moon also rotates, but with the same period, so it takes the same amount, right? So, sorry, the Earth rotates 28 times, 28 rotations, right, for one full revolution of the moon. Okay, so say the first day of the moon, the first day of the month, the moon is here, the second day would be here, and so on. You're gonna need to draw 28 moons here, right? And during this whole month of 28 days, you're gonna see the moon in these different phases, okay? And what you're gonna find out is that not every day you're gonna be able to see the moon in the night in the sky. For example, as we have already discussed, right? So this would be your horizon if you are here and looking up, right? You're never going to see a new moon in your night sky, right? So this is day and this would be night when the new moon phase is up in the sky. Okay, so the new moon is basically up at noon, at 12 p.m. You're never ever going to see a new moon during the night. Same for the full moon, right? Only during the night you see it. And also, as it was mentioned in the other pages here, the moon, when it's a bit fuller, right, like when it's a gibbous like this, whether waxing or waning, you can see that kind of moon during the night sky, while the new moon or the waxing crescent or the waning crescent, you're going to see them basically during the day or very late in the evening or very early in the evening. So actually, let's try to figure out, for example, when one of these phases of the moon arises, or you expect them to rise and set. Okay, so look at that rotation, right? So the Earth rotates like this, the Moon goes in this direction, right? Okay, so for example, the new moon, in order to see it, it needs to be when it's highest in the sky, it's noon. But when was it that it went above your horizon? When it went above the horizon at, look at that, 6 a.m. So that means this is when it rises, the new moon. New moon rises. When will the new moon, so it's the highest at 12 p.m. or at noon, and it's going to go under your horizon, right? So this is the time at which new moon sets. Okay? So you can do the same thing now with some other times. Say we want to figure out the setting, the rising times for the waning gibbous. All right, what are you gonna need to do? You look at it, you need to be looking up, straight up at 3 a.m., right? That's gonna be the time the waning gibbous is gonna be highest in the sky. Okay, it turns out that in order for that to happen, this will be your horizon, right? So horizon to see the waning gibbous. At its highest. Okay, so given that you identified your horizon for that particular situation, that looks like it's going to be 9 p.m. the time this waning gibbous rises, and then it's going to set at 9 a.m. So practice with that. So let's test some things we discussed with a question like this. Assume it's 9 a.m. You're looking at the sky and see a moon with half its face bright and half dark. Of course, we are talking here about the face that is towards us, the Earth, or the face that we see. All right, so if it's half of the face that we see, you already can tell we are going to see what kind of face is going to be a quarter of the whole moon. So again, quarter. So it's not going to be a gibbous, and it's not going to be anything like half moon. It's either the first or the third. How are we going to figure that out? All right, so let's look at these diagrams. We have the sun's light coming that way. This is going to be the new moon. Of course, this is going to be 12 p.m. or noon. This is midnight or 12 a.m. Dawn, 6 a.m. and 6 p.m. here. Where is that quarter, right? The third is here, and the right, this is the part that's illuminated, this is the part that is illuminated, this is the first quarter. All right, so now let's use the information that is 9 a.m. So where is 9 a.m. gonna be? 9 a.m. So I'm here, I'm looking up. Where is my horizon? Show your horizon. It's going to be very important, right? So horizon, it's going to be perpendicular, right? That line perpendicular to where you're standing up. your horizon at 9 a.m. So what's above your horizon, right? So this is above the horizon, and here is going to be under the horizon. So what is it that you're going to see? It looks like of these two quarters, the one that you see is the third one. So the correct answer will be third quarter. All right, so good luck with practicing this. I think it's going to be fun to figure out when during the day you're going, or in the month, you're going to see the different phases of the moon about which you learned today.